Hi, my name is Darius Quick. In this presentation, I will outline the process I follow to create a fully functional website with cloud storage and database capabilities. There were two ways we used to migrate our code to the cloud in this course. The first way we used to migrate our data to the cloud was by using the command shell, MongoDB, and Docker. First, we had to make sure that MongoDB was set up for use using the command shell and that our program was set so that the back end and front end data could be uploaded as images into Docker. We then had to create Docker files for the necessary configurations to be set so that Docker can correctly build an image for our front end and back end application data and use the command shell for the functionality to make this work. We then use the command shell to create a shared network so that our MongoDB database, API, and UI can work together. Next, we created YML files or YAML files to define the services, network, and storage volume our application will use. Lastly, we use Docker Compose Up on the command shell to create images of our application, then containerize them. Docker is a useful tool to use when you have multiple applications that must work together to handle a project. The applications can be containerized so that they are easily able to be run and work together. Using Docker Compose commands in the command shell will make building an image and slash or containerizing an image easier. This is an image of the Docker Compose Up command being used in Windows PowerShell 7. The second way that we migrated our application to the cloud was using Amazon AWS tools. The tools I used to migrate my full stack application to the cloud and create a database system for it were Amazon AWS's S3, Lambda, DynamoDB, and API Gateway. I use S3 to hold the files necessary and host the static website's front end web page. Lambda was used to create and test the functions that will be used in the serverless website for CRUD, which stands for Create, Read, Read All, Update, and Delete, and option functionality. We then use API Gateway to test if our API with a parameter could call a Lambda function. Next, we use DynamoDB to create two database tables that will be used to hold the data that our Lambda functions would access, called questions and answers, holding data representing each table and testing each to make sure it functioned properly. Lastly, we use API Gateway to create an API slash backend web page for each of the database tables we had created and tested to make sure that both the backend and front end websites worked. When developing an application, you can create and execute apps using serverless computing without having to worry about maintaining servers. Serverless computing's benefits include lower operating overhead, automated scaling, and cost effectiveness. While virtual storage is a more general phrase that encompasses a variety of technologies that produce virtualized storage resources, Amazon S3 is a cloud based object storage service. S3 offers scalability and durability by concentrating on storage and retrieving data as objects. Conversely, virtual storage can include virtual drives, virtual machines, or file writing via an API, frequently with the use of underlying physical storage. This is an image of a serverless process UML diagram. Both Docker and AWS provide elasticity and use the pay for use model. Elasticity allows us to scale up or down depending on required resource. Pay for use only charges for the resources that are utilized. Amazon Web Services provides S3 or Simplified Storage Service, a cloud storage solution that can store and retrieve any volume of data. In contrast to local storage, it provides pay as you go pricing, great durability and availability, and nearly infinite scalability, making it perfect for a variety of applications, including those that use serverless architectures. Docker has a subscription plan that provides an amount of scalable data use and charges based on the subscription plan chosen. This is an image of AWS graphs comparing capacity versus usage. Both MongoDB and DynamoDB are NoSQL databases or non-relational databases. In the next slides, you'll see the data model differences between MongoDB and DynamoDB. With MongoDB's database, within collections, MongoDB stores data as adaptable documents that resemble JSON. There's flexibility in the schema because these documents might have different structures. Supports many different data types, including arrays, embedded documents, and different date and numerical formats. Individual documents have a maximum size of 16 megabytes. Greater binary data can be extended using GridFS. The flexibility of the schema provides schemaless design by default, but when necessary, it permits schema validation to impose structure. With DynamoDB, the store is primarily a key value store, but it also allows you to store JSON documents inside of objects. Strict primary key specifies how data is retrieved and disseminated by requiring each item to have a primary key, partition key, and optional sort key. Restricted data types, in contrast to MongoDB, it supports a smaller range of data types. The maximum item size of each item can only be 400 kilobytes in size. Flexible schema with primary key restrictions. The basic key structure is hard and essential for performance, but it can be a variable within an item. It is very important to know the differences between the databases MongoDB and DynamoDB. For Docker, unauthorized access is blocked behind your user account that the applications are containerized under, and additional authentication can be created utilizing the command shell. For Amazon AWS, unauthorized access is blocked by not only your user account and role, but policies that define what user roles should be allowed to do and access. Also, AWS Bucket/websites has specific permission and policy settings that can limit access to them. We created a JSON policy for our S3 bucket, but made it publicly available because it was a learning experience. The connection between API Gateway and Lambda is secured by using API keys. AIM roles are used for securing data between Lambda and DynamoDB. This is an image of the AWS IAM permissions policy for my user role while I was doing my project. Thank you, everyone. In this presentation, I explained multiple ways of how migration is used, the concepts of serverless cloud and how it differs from virtual storage, how the front end interacts with the back end to create a functional website, and how both migration methods can be used to prevent unauthorized access.